What does it mean when we say we have two similar figures?
Hello everyone, welcome to my YouTube channel.
What does it mean when we say we have two similar figures? Similar figures can be thought of as a figure and an enlargement or reduction of that figure without any distortions. Scale models are one way that the concepts of similar figures is used. For two polygons to be considered similar, their corresponding angles must have the same measurement, and their corresponding sides need to be proportional. The ratio of the lengths of corresponding sides in two similar figures is the similarity ratio. Let's look at some examples. We have two pentagons, night and power, that are similar. Therefore, we know that the corresponding angles must be equal. So, what is the measurement of angle R? Well, angle R corresponds to angle T, so the measurement must be 120 degrees. We also notice that side IG corresponds to side OW. So, what is the similarity ratio of night to power? Side IG is 8 centimeters, and side OW is 10 centimeters. So the ratio is 8 to 10, which simplifies to 4 to 5. What if I ask for the similarity ratio of power to night? Well, that would be 10 to 8, or 5 to 4. And if I only asked for the similarity ratios for this problem, then either answer would be correct. Now, how can we use this information? We know that the side WE measures 8 centimeters, so we can find the length of GH by setting up a ratio, since GH is the corresponding side in night. The ratio of night to power is 8 to 10, and X and 8 are the corresponding measurements. The X is located on the polygon night, so we would put it across from the 8 centimeters in our ratio, and the 8 is in the polygon power, so we would put it across from the 10. Now we can solve for the length of X by cross-multiplying. So we get 10x equals 64, or x equals 6.4. So, side GH is 6.4 centimeters long. We are told that NI is 7.2 centimeters and PO is n plus 2 centimeters, and we wanted to find the value of n. Again, we will set up our similarity ratio. Remember, we are still looking at night and power, so our ratio is 8 to 10, and 7.2 and n plus 2 are the measurements of the corresponding sides. Again, we will use cross-multiplying to solve this problem. That is 8 times the quantity n plus 2 equals 72. Now, don't forget to use the distributive property to remove the parentheses. That gives us 8n plus 16 equals 72. 8n equals 56, n is equal to 7, and side PO would be 9 centimeters. Now, let's see if we can help out Sam. Sam needs to determine the height of the tree closest to the school. When he stood his yardstick perpendicular to the ground, he found that the shadow was 4 feet long. Then he measured the length of the tree's shadow, and it was 24 feet long. How tall is the tree? Pause the video while you try and figure out the height on your own. Then unpause the video and check your answer. Well, we are going to be looking at the ratio of the yardstick to the tree. That ratio is equal to the yardstick's shadow, which is 4 feet, to the tree's shadow, which is 24 feet. And that would be equal to the ratio of the height of the yardstick to the height of the tree, which is what we are trying to find out. 4 over 24 is 1/6. So we can reduce the fraction and then cross-multiply to find the answer, which leaves us with x is equal to 18. So the tree is 18 feet tall. Similar figures problems occur in real life, whether one is measuring the height of a tree or making a scale model before working on a large project. Being able to find the similarity ratio, or the scale, and knowing how to calculate dimensions are useful skills to have.
Thank you for watching.